At a particular bay, high tide occurs at 2 a.m. and reaches a water level of 12 meters. So at 2 a.m., the water level is up at 12. And low tide occurs at 8 a.m. and it reaches a water level of 0. And we're going to assume that we start counting time equals 0 is midnight. We want to draw a graph to describe this motion and write an equation to model the function. So if we go from high tide to low tide, our graph would look like that. Notice that that is 1, 2, 3, 4, 5, 6 hours over. So if we continue 1, 2, 3, 4, 5, 6 hours over, we would be back up at 12 meters. So continuing our function, it looks like this. If we went backwards 6 hours, 1, 2, 3, 4, 5, 6, we would be back down at 0. So there's a rough sketch of what our graph is going to look like. If we start at a high point, the easiest way to write an equation would be in terms of cosine. Y equals A times the cosine of B times x minus C plus D. And our amplitude would be our highest point minus our lowest point divided by 2. You could also think of that as being, if you drew in the midline of the graph, how high above it that midline the graph went and how far below. And in this case, 12 minus 0 is 12, divided by 2 is 6. To find B, we're going to need to find our period. And if you noticed, it took 6 hours to went from high tide to low tide and 6 more hours to go from low tide to high tide. So overall, our period is equal to 12. And period is equal to 2 pi over b. So 12b is equal to 2 pi, which means that b is equal to pi over 6. Our graph is shifted 2 units to the right since we started at high tide. So that is x minus 2. And our vertical shift is wherever the midline of the graph is, which in this case is at 6. So our equation is y equals 6 times the cosine of pi over 6 times x minus 2 plus 6, or we might write this in terms of t for time. And so we have 6 times the cosine of pi over 6 times t minus 2 plus 6.